Hi, my name is Susan Wingerter, and this is for course STEM 300, Module 8. And I'm going to be walking through a little bit a coding program called Scratch. I work for a small independent school here in Chicago as an assistant teacher, and this year in the second grade. And this school uses Scratch in its TESS lab or technology, engineering, and sciences lab courses to teach young learners about coding. So I'm going to share my screen with you and we can have a look at what Scratch is. Scratch was developed in 2007 by a Professor Mitchell Resnick, who created the group, the Lifelong Kindergarten group at MIT's Media Lab, the Massachusetts Institute of Technology. And he developed this to help young learners learn how to code. And the way that it works is it uses something called block coding. And the block coding, it turns programming, which is what you're designing the computer to do, into a drag and drop process. And it converts technical function code into a code using visual blocks. And I'm going to show you what that looks like. So here we're going to explore. Let's explore a little bit. I notice that there are some animations here that have been made by programmers here with Scratch. And this is an example of one of the things that a student could make using Scratch. So it's going to load this project and we're going to click the green flag to see what it's doing. The programmer has added music. It's got a little character there who's doing some dancing. And they've created all of this using a drag and drop process. We're going to have a look inside. It says see inside here. We're going to look inside and see how they did that. You'll notice that on the left side of the screen, there are these blue blocks. These are motion blocks. And so what you can do is you can take a block through motion. Purple is looks, something that they would say. Pink is sound. Yellow is events. So for instance, when the green flag is clicked, then the next thing is going to happen. Controls such as waiting or repeating, and if and then, and wait until and repeat until functions. Sensing, what the character senses you are doing with the computer. Operators, for one character to do something with another character or have a function, I just pick something up and move something over. Variables, things that are changeable within the blocks, and then blocks that you build for yourself. And you can see that the animation that we were looking at before that a program had made, these are all of the functions. So first it moves 10 steps, and afterwards it's going to turn 15 degrees, and then turn another 15 degrees, then go to a random position, and now it's added more characters. And you can see as you go through the lines of blocked code, how every bit of it is moving along as the code is moving. I'm going to stop it using the stop sign. And I'm going to show you how we can create a little something as well. We're going to go back to the beginning of Scratch, and we're going to create something so that I can show you how it works. This engages learners by showing them how to combine these drag and drop blocks to create animations in games. And what's great about that is that it shows them a real life in time example of cause and effect. If you start with a little sprite, they've given me a little orange cat to start off with, and you begin with a motion, move 10 steps, you can automatically see that you've programmed the cat to move, right? You can put a look. Maybe we want the cat to say hello. Maybe we want the cat to say meow. And you can see how there's little links here. Each block has a link, and every block is floating into the next link. Maybe we want to start it when the green flag clicks. Maybe we want to only go 5 steps. Maybe we wanted to say greetings. And so when we click on our green flag, The sprite should do exactly what we've asked them to do. Greetings. And then when you're finished, or if you want to change something, you just move it right back. And you can choose your choice of sprite as well. Maybe I don't want a kitty cat sprite. Maybe you want a different maybe I want a different sprite. Maybe I want to have a beetle. And when the green flag is clicked, I want the beetle to start a popping sound. And then I want it to wait 10 seconds and then move 5 steps. Let's see what the beetle does. Stop. Start popping sound. Maybe we'll put the popping sound back and maybe we'll start sound. I'm going to record myself. I am a beetle. I am a beetle. Hello. We're going to save it. I am a beetle. Hello. And then we're going to go back to our code. Recording 1. Let's see. I am a beetle. Hello. What's amazing about this is that students can really see their work reflected right away. They don't have to wait to look at the back end as, the front end as a user. There is no real coding vocabulary taught through this app. Instead, what it does is it shows a good way to learn the concepts and structures of programming. It doesn't introduce any formal language, not the formal language that actual programmers use. So this is good for young learners who are still developing their own language through reading and writing, pre-K, kindergarten, first grade, emerging second graders. And I think this is a really beautiful way to show students what coding can look like. Even though Scratch doesn't teach a coding language, it introduces the fundamentals of coding concepts, particularly loops. It has variables, it has conditions, and students they can really see the results of what they're doing, and they can understand that you can do pretty much any animation and any variable of thing that you want to do. You can create games. There's a joystick function. Um, you can use someone else's creation and then remix it. I wonder if we can go back to our animation and then remix it and see what happens. What's great about this is it's very user friendly. You can explore for a long time. Ah, and you can change it if you want to. I see. I 100% recommend this app. I recommend this app because it's equitable for all learners. It doesn't matter your skill level. It doesn't matter your language. It doesn't matter your vocabulary sense. It focuses on the logic behind coding, but it doesn't get stuck if there's a typo in the syntax. So for instance, if I were to type out move 10 steps with the proper syntax and punctuation and I forget a semicolon, then the program isn't going to do what I'm designing it to do. This drag and drop block system takes that out of the equation for learners who aren't quite yet at that developmental skill set to understand that language. It's also free. This is completely free to play with and completely free to use. You can use this at home. Your students can use it at home. You can use it at school. Schools can implement this at school. And so I feel like I would recommend Scratch to teach coding concepts and coding fundamentals to students as young as, I mean, very small children are playing with phones and iPads at the age of 4. I know my nephew's playing from the age of 4 all the way up until around the second grade, maybe third grade, when you start to your vocabulary will grow, and that you can start being introduced to more functional language. And so that's it. That's me sharing Scratch. Get out there and try it. It's super cool. Okay, have a good day.